Gedanken conditions exist in this example. A stationary observer on Earth sees a very fast car travelling by at 2.5 times 10 to the 8 metres per second. When stationary, the car is 3 metres long. Calculate the length of the car as seen by the stationary observer. Use c equals 3 times 10 to the power of 8. All right, so if you are in the same frame of reference as the car, you would measure the car to be 3 metres long. So that is our L0 value. Okay, so if you were stationary relative to the car, you would measure the car being 3 metres long. But we are not. We are moving at a relativistic speed relative to the car, so we need to find L. So in order to do this, we need to work out our Lorentz factor, which is equal to 1 over the square root of 1 minus v squared on c squared. And I think this is very similar to the Lorentz factor we did the other day. So we can do 1 over 1 minus, now remember we don't need the times 10 to the 8, so it can just be 2.5 squared over 3 squared. Is that 1.8?
Got no idea.
I'm thinking it is. Double check for me, but I'm pretty sure it's 1.8.
Did you do that again?
Yes, yes.
I got it.
Yep.
1.8
No, not really.
1.8.
Yeah, it is anything.
1.8. Okay, so our Lorentz factor is 1.8. Now, from our formula, our measured length outside that frame of reference is equal to L0 divided by our Lorentz factor. So it is 3 divided by 1.8, which is, little help, 1.65.
So tricky.
So the car travelling at a relativistic speed with a Lorentz factor of 1.8 will shrink from 3 metres to 1.65 metres if you are outside the frame of reference. Now remember, if you are inside the car, you'll still measure 3 metres. Okay, you're in that frame of reference. But if there was another car parked that was 3 metres long at rest, if you're going past that, you will see that one at 1.65. Okay, so this length is what happens if you're outside the frame of reference, whereas L0 is when you're inside the frame of reference.
So you wouldn't feel that if you were inside.
Well, no, there'd be no effect at all. As far as you're concerned, if you're inside, you're still in a 3 metre car.
It's a big